Welcome to another video lesson on statistics and probability. Our topic for today's discussion is about finding the mean and variance of the sampling distribution of the sample mean. At kung bago ka pa lang sa channel ko, don't forget to subscribe, like, and share. Objectives: compute the mean and variance of the sampling distribution of the sample means and define sampling distribution of the sample mean for normal population when the variance is known and unknown. Can you still remember the steps in finding the mean and variance of a discrete random variable? So in this lesson, we will study on how to find the mean and variance of a sampling distribution of the sample mean. To start with, let us have example number 1. Mark is conducting a survey on grade 12 students of Nacionalismo High School. He found out that there are only few students who knew about the makers of the Philippine flag, consisting of 1, 2, 3, 4, and 5 senior high school students from 5 sections. Suppose that the sample size of 2 sections were drawn from the population. It's without replacement. Describe the sampling distribution of the sample means. 1. What is the mean and variance of the sampling distribution of the sample means? And second, compare these values to the mean and variance of the population. Since we are asked to compare the mean and variance of the sampling distribution of the sample means to the mean and variance of the population, let us start by computing the mean and variance of the population. The formula for the mean of the population is summation of x divided by the population size. So with that, we have our populations are 1, 2, 3, 4, and 5. So summation of x is equal to 1 plus 2 plus 3 plus 4 plus 5 divided by the population size, which is 5, equals 15 divided by 3 divided by 5 is equal to 3. For us to get the variance, we have this formula. And for us to get it, we have it's in a tabular form. Since we know that the mean is 3, our populations are listed down under x. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Next step is to square on what we had obtained from this column. So we have x minus mean squared. So negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is equal to 4. Then, after that, we just have to add x minus mean squared. We have 10. Going back to the formula, we have summation of x minus mean squared is equal to 10 divided by the population size equals 5. So 10 divided by 5 is equal to 2. The population mean is 3 and the population variance is 2. And that's it. Now that we are through solving for the population mean and the population variance, let us now proceed on finding the mean and variance of the sampling distribution of the sample mean. First step is to determine the number of possible samples to construct a sampling distribution of the sample means. Again, we will use the combination formula. So, population size, combination of sample size. Our population size is 5 and the sample size is 2. With that, we'll be using this. We'll just have to substitute the population size in the given formula. So, we have 5 factorial divided by 5 minus 2 factorial, 2 factorial. We know that 5 factorial is 5 times 4 times 3 times 2 times 1. So let us first subtract this. 5 minus 2 is 3 factorial, 2 factorial. Moving on, we have 3 factorial at the denominator, so it's much easier if we have 5 times 4 times 3 factorial. So that when I have 3 factorial at the denominator, this 2 is equal to 1. So we have 5 times 4 times 2 factorial is 2 times 1. Another trick there is that we can divide 4 by 2, and this is 2. So we have 5 times 2, 10. Divided by 1, still it is 10. So the number of possible random sample that we have to list down on our next step is 10. So let us proceed to the second step. Now that we have determined the number of possible samples that we have to list down, taken from the population 1, 2, 3, 4, and 5. Take note that we have to list down 10 possible random samples from the combination of 5, taken 2 at a time. So with that, from here, we will have to list down 2 samples from here, starting from 1, 2. So, ganito lang yan. Next is 1, 3. Next is 1, 4. Then, 1, 5. So, we're done with samples beginning with 1. Let us proceed to the next one. 2, 3, 2, 4, and 2, 5. Ganyan lang siya. And then, tapos na tayo sa 2, punta naman tayo sa 3. 3, 4, and 3, 5. So, wala na kasi nasa dulo na ulit. And then, syempre yung last, 4, 5. So, yun yung mga samples na kailangan natin. Dahil sabi niya, size 2. So, dalawa-dalawa. Mula dyan, kukuhanin na natin ang mga means ng mga sample natin. Paano kuhanin ang means? Syempre, i-divide lang natin siya. I-add at i-divide. So, ilan yung addends? 1 plus 2 divided by 2 is 1.5. 1 plus 3 is 4 divided by 2, 2. 1 plus 4 is 5 divided by 2, 2.5. 1 plus 5 divided by 2 is 3. 2 plus 3, 5 divided by 2, 2.5. 2 plus 4 divided by 2 is 3. 2 plus 5 divided by 2, 3.5. 3 plus 4 ay 7 divided by 2, 3.5 ulit. 3 plus 5 is 8 divided by 2, 4. And then 4 plus 5 is 9 divided by 2, 4.5. So, ito na ngayon yung mga samples at ito na ngayon ang mga sample means. Ang next step niyan ay gumawa na ng sampling distribution of the sample means. So, itong mga means natin ngayon ang ating magiging X. Gagawa ulit tayo ng table. Sample means, ito nga yung magiging X natin. So, from there, kung sila yung mga X natin, ilista na natin sila isa. From lowest to highest. So, 1.5, 2, 2.5, 3, 3.5, 4, at saka 4.5. Kung nakikita nyo, 2.5 ay dalawa. Pero hindi natin siya ililista bilang dalawa. Saan mag-a-appear ng dalawa siya? Sa frequency yon. Same with 3.5. So, bilangan natin, ilan ang 3.5? Ang 1.5? Isa lang. So, 1 ang ilalagay natin sa frequency. Ilan ang 2? Bilangin, meron pa bang 2? Wala. So, 1 pa rin siya. 2.5, dalawa sila. That's why it's 2. And then, 3, there are 2, 3. So, kaya dalawa ilalagay natin dito. Dalawang 3.5. So, 2 din siya. Isang 4, isang 4.5. So, yun na. Ngayon, kung bibilangin natin yan, take note na itong samples natin ay 10. Dapat pag inad natin itong frequency, 10 din siya. After that, yung mga frequencies na yan, kuhanan natin ng probability. Itong mga sample size natin. Ilan ba ang 1.5 out of 10? So, 1 over 10 or 0.10. Ang 2, anong probability ng 2? So, 1 over 10 din or 0.10. Ang 2.5, dalawa sila, 2 over 10 or 0.2. 3, 2 over 10 or 0.2. 3.5, 2 over 10 or 0.2. Ang 4, isa lang siya, 1 over 10 or 0.10. 4.5 is 1.10 or 1 over 10 or 0.10. So, ganyan. Ganyan gumawa ng sampling distribution of the sample means. So, ito na yon. Now that we have the sampling distribution of the sample means, let us compute for the mean. Sampling distribution pa lang kasi ang ginawa natin. Ngayon na meron na tayo nito, ang next step na ay mag-compute na ng mean. To compute for the mean, we know that the formula for this is just the summation of the product of x and the probability of x. Multiply lang natin itong dalawang to. So, 1.5 times 0.10 is 0.15. 2 times 0.10 is 0.20. 2.5 times 0.20 ay 0.50. 3 times 0.20 is 0.60. 3.5 times 0.20 is 0.70. 4 times 0.10 is 0.40. And 4.5 times 0.10 is 0.45. Adding this will give us the mean. So, the mean of the sample mean is equal to 3. Kung napapansin nyo, so the mean of the sample mean is 3. Next step, compute for the variance. For us to compute for the variance, yung galing sa sample mean, sampling distribution of the sample mean natin, itutuloy na natin dito. Tatanggalin na natin yung frequency na column. So, ito pa rin yung mga sample means, yung probability. Since alam natin na ang mean ay equal sa 3, mag-proceed na tayo sa next column para makompute natin ang variance. Next column is x minus mean. So, ito yung x natin. 1.5 minus 3 is negative 1.5. 2 minus 3 is negative 1. 2.5 minus 3 is negative 0.5. 3 minus 3 is 0. 3.5 minus 3 is 0.5. 4 minus 3 is 1. And 4.5 minus 3 is 1.5. Ayun. Yun yung tapos na tayo sa column na yan. Ang sunod, itong column na to ay isa-square natin. Ibig sabihin ng isa-square. Negative 1.5 times negative 1.5. Kaya, we have 2.25. So, with that, negative 1 times negative 1, 1. Negative 0.5 times negative 0.5 is 0.25. Siyempre, 0 times 0, 0 siya. 0.5 times 0.5, 0.25. 1 times 1, 1. 1.5 times 1.5 ay 2.25. Yun yung sunod na step. Sunod na is, i-multiply na natin ito at saka yung probability. With this, 2.25 times 0.10, ito na, 0.225. 0.10 times 1 is 0.1. 0.25 times 0.20 is 0.05. Then, 0.2 times 0, syempre 0 yan. So, times next is 0.25 times 0.2 again. We have 0.05. 1 times 0.10 is 0.10 or 0.1, that's the same. 2.25 times 0.10 is 0.225. Then, after that, i-add na natin to, and we have the variance itself. Because variance is the summation of the probability of x times the square of x minus mean. So, i-add lang natin to, and we have our variance. So, kung i-compare natin, the variance of the sampling distribution is 0.75. Kung i-compare natin, note that the population mean is equal to the sample mean of the sampling distribution. So, kanina, ang nakuha natin sa population mean ay 3. Ang nakuha natin sa sample mean ay 3 din. Tingnan nyo, under property ng sampling distribution of the sample mean, parehas sila ng mean. Yan. So, the mean of the population is equal to the mean of the sample mean. And then, with that, this happens because all samples of n size came from the same population. Kaya daw ganun. Kaya parehas ang mean ng population at saka ng sample kasi iisa lang naman yung data. The variance of the population is greater than the variance of the sample means. Since a sample of n is less than the population of n, then the data vary by a small amount as compared to the population. So, ito naman, with regards to variance, ang variance daw ng population ay mas malaki kesa sa sample mean dahil ang sample ay parte lang ng population because this sample is just apart from the population. So, kaya mas malaki daw ang population ng ang variance ng population. Ayun yung explanation doon. Remember this. Mean of the sampling distribution of the sample mean is mean of the sample mean is equal to mean of the sampling distribution is equal to the summation of x times the probability of x. And then the variance of the sampling distribution of the sample mean is equal to ito yung ginamit natin kanina, or pwede rin daw ito, or ito. Yung kung meron ka ng variance of the population, pwede mo nang gamitin to if the given is finite. Population. Finite meaning meron siyang fixed number of population. Ito naman yung formula kapag ka infinite population. So, ito naman pag infinite, indefinite ang number ng population. Walang hanggan ang number ng population mo. Kaya ito ang gagamitin. For as long as you have the variance and the number of sample size, you can use this formula to find for the variance of the sample mean. So let's have example number 2 for you to be familiarized with the steps in finding the mean and variance of the sampling distribution of the sample means. So first step is to compute for the population mean and variance. So with that, we have the following population, 9, 5, 6, 12, and 15. Let us get its mean, its summation of the population divided by the population size. So we have 9 plus 5 plus 6 plus 12 plus 15 is equal to 47 divided by 5. And 47 divided by 5 is equal to 9.4. So yan ang mean natin. Then, we will now proceed to finding the variance. Sa variance, itabular form na natin sila. Ang second column, na-list down na natin yung x. Ito yung population na 9, 5, 6, 12, 15. Yung next step ay x minus mean. Ang mean natin ay 9.4. So, 9 minus 9.4 is negative 0.4. Then, 5 minus 9.4 is negative 4.4. 6 minus 9.4 is negative 3.4. 12 minus 9.4 is 2.6. And 15 minus 9.4 is 5.6. Next step ay square na natin yung nakuha natin sagot dito. So, squaring it, Negative 0.4 times negative 0.4 is 0.16. Negative 4.4 times negative 4.4 is 19.36. Negative 3.4 times negative 3.4 is 11.56. 2.6 times 2.6 is 6.67. And 5.6 squared is 31.6. After nyan, itong nandito sa third column, i-add up lang natin siya. So, summation of x minus mean squared is equal to 69.2. So, saka na natin makukuha yung variance. Since ang variance, ang formula niya ay summation of x minus mean squared divided by the population size. So, yung nakuha natin dito, ito yun, 69.2 divided by 5. Variance of the population is 13.84. Kinukuha natin to para in comparison with our mean and variance of the sampling distribution. So, tapos na tayo sa population mean tsaka population variance. Pumunta na tayo in finding the mean and variance of the sampling distribution of the sample mean. So, una parating step pag nasa sampling distribution of the sample mean na is to determine the number of possible samples of size 2. So, nakastate naman niya sa problem. And then, the population size is 5. For us to determine that, we'll use the combination symbol. So, mangyayari is equal to 5 factorial divided by 5 minus 2 factorial, 2 factorial. So, copy ulit yung numerator na 5 factorial, tapos 5 minus 2 factorial ay 3 factorial, 2 factorial. So, sa denominator kasi may 3 factorial, kaya para mas madaling mag-simplify, 5 times 4 times 3 factorial. Para 3 factorial and 3 factorial is 1. So, ang matitira dyan, 5 times 4 is divided by 2 factorial na 2 times 1. 5 times 4, 20. 2 times 1, 2 equals 10. Yung isa pang step na tinuturo ko, pwedeng mag-divide ng 4 at saka 2. 4 divided by 2 ay 2. Kaya 5 times 2, 10 pa rin. So, yan ang kailangan natin i-list down. Yung 10 possible outcome. Ang step 3, maglilista na tayo ng mga possible samples taken 2 at a time. So, ito yung population natin. Dito tayo kukuha na magiging samples natin taken 2 at a time. So, dalawa-dalawa. Sabi dyan 10. Kaya dapat 10 ang malista mo. To start with, simulan natin sa 9. Parang nagdi-distribute ka lang din, ganyan. 9, 5, 9, 6, 9, 12, at saka 9, 15. Ayun. So, tapos ka na sa 9. Punta ka naman sa 6. Sa 5, I should say. 5, 6, 5, 12, tsaka 5, 15. Tapos ka na sa 5, punta ka naman sa 6. 6, 12, 6, 15. Okay, tapos ka na dyan. And then, 12, 15. Yun yung last. Then, next ay yung mga means. Mean lang ng mga to. So, 9 plus 5 ay 14 divided by 2, 7. 9 plus 6 is 15 divided by 2, 7.5. 9 plus 12 divided by 2, 10.5. 9 plus 15, 24 divided by 2, 12. 5 plus 6, 11 divided by 2, 5.5. 5 plus 12, 17 divided by 2, 8.5. 5 plus 15, 20 divided by 2, 10. 6 plus 12, 18 divided by 2, 9. 6 plus 15, 21 divided by 2, 10.5. And 12 plus 15, 27 divided by 2, 13.5. So, ayan na. Nakuha na natin lahat ng mga means ng mga possible samples natin. Sunod niyan ay gumawa na talaga na sampling distribution. Ito na, step 4. Sampling distribution na. Nilista ko na isa-isa yung mga means kasi yan yung magiging x natin. Mula sa pinakamababa hanggang sa pinakamataas nang hindi inuulit. 5.5, sunod ay 7, 7.5, 8.5, sunod 9, 10, 10.5, 12, 13.5. Tapos bilangan natin, ilan bang 5.5 meron sa data? Isa. Okay, 1. Ilang 7? Isa lang din. Ilang 7.5? Isa lang din. 8.5? Isa lang din. 9? Isa lang din. 10? Isa lang din. 10.5? Ayan, dalawa. Kaya hindi natin nilalagay dito ng dalawang beses kasi dito natin sila i-appear sa frequency kung ilan beses sila nag-appear as mean dun sa possible samples. 12, ilan ang 12? Isa lang din. And then 13.5, isa lang din. That's it. Tapos pag inad mo yan, syempre, dahil 10 yan, 10 dapat ito. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ayan, 10. Let us get the probability of 5.5. Siyempre, ang frequency niya, isang beses lang siya nag-appear. 1 over 10 or 0.10. 7, ang 7 ay 1 over 10 or 0.10 din. 7.5, 1 over 10 or 0.10 din. 8.5, 1 over 10 or 0.10 din. 9, 1 over 10 or 0.10 din. 10, 1 over 10 or 0.10. Ang 10.5, dahil dalawa siya, 2 over 10 or 0.2, then 1 over 10 or 0.10, 1 over 10 or 0.10 ulit for 13.5. So this is now the sampling distribution of the sample means. So after computing for the mean and variance ng population, let us now proceed on finding the mean and variance of the sampling distribution. So, nakagawa na tayo kanina na sampling distribution. Kukuhanin lang natin yung mga sample means na nandoon. Ito na yon. And then, yung probability, ilista mo ulit. And then, our next step, para makapag-compute tayo ng variance is following the second step that get the difference of the sample means and the mean. And then, square natin. And then, i-multiply natin yan sa probability of x. So, alam natin kanina na ang mean na nakuha ay 9.4. So, take note, isa sa property na ang mean ng population at ang mean ng sampling distribution are the same. So, hindi na natin kailangan mag-compute ng mean galing sa sampling distribution kasi alam natin na parehas lang sila. So, pwede na natin gamitin yung na-compute nating mean mula sa population. So, ito ulit yung explanation yan. Ito ulit yung explanation yan na parehas ang size ng population tsaka parehas ang value ng population mean at tsaka ng sample mean. So, let us now continue with our next step. Let us get the difference of the sample means and the mean. So, 5.5 minus 9.4 is negative 3.9. 7 minus 9.4 is negative 2.4. 7.5 minus 9.4 is negative 1.9. 8.5 minus 9.4 is 0.9. 9 minus 9.4 is negative 0.4. And 10 minus 9.4 is 0.6. 10 minus 9.4 is 1.1. 12 minus 9.4 is 2.6. And then 13 minus 9.4 is 3.6. After nyan, after yung portion na to, isa-square naman natin tong lahat na to. So, start with negative 3.9 times negative 3.9. Ito, the product is 15.21. Negative 2.4 times negative 2.4 is 5.76. Negative 1.9 times negative 1.9 is 3.61. Negative 0.9 times negative 0.9 is 0.81. Negative 0.4 times negative 0.4 is positive 0.16. 0.6 times 0.6 is 0.36. 1.1 times 1.1 is 1.21. 2.6 squared is 6.76 and 3.6 squared is 12.96. After nyan, We will now multiply this obtained value to the probability so that we can have the product of the probability of x and the x minus mean squared. So, 15.21 times 0.10, yun, 1.521. 5.76 times 0.10, 0.576. 3.61 times 0.10, 0.361. 0.81 times 0.10, 0.081. 0.16 times 0.10, 0.016. 0.36 times 0.10, 0.036. 1.21 times 0.2 is 0.242. 6.76 times 0.10 is 0.76. And then 12.96 times 0.10 ay 1.296. After nyan, i-add natin to at yan ang magiging variance natin. 4.81. So mind this, in computing for the variance of the sampling distribution of the sample means, you may use the formula. Ito yung ginamit natin kanina. Or, ito ginagamit ko kung finite. Sampling without replacement. So, kung kuha mo na yung population variance at gusto mo nang mag-proceed ka agad sa finding the variance of the sampling distribution of the sample mean, pwede mo nang gamitin ito. Basta finite. Meaning, yung population mo ay may hangganan or exact lang, finite lang talaga. Ito naman, for infinite population, ito naman yung gagamitin mo for as long as dito wala siyang sample size kasi infinite population siya. You cannot determine the number of population. So, basta present na or meron ka ng value ng variance, pwede mong gamitin to tanggang dalawang formula na to for finite tsaka for infinite kapag ka finding the sample, the variance of the sample mean. Also, the standard error of the mean is computed using standard deviation of the population divided by the square root of the sample size. We also have defining sampling distribution of the sample mean for normal population when the variance is known and unknown. So, the distribution of the sample mean for normal population, number 1, population variance is known. It is known when the population has a mean and variance. The distribution of the sample mean is normal and standard error of the mean is standard deviation of the population divided by the square root of the sample size, wherein the symbol sigma is the population standard deviation and the small letter n is the sample size. To determine the probability of a certain event, we can use the z distribution by transforming the mean of the sample data to an approximately normal variable z. Using the relation z is equal to x minus mean divided by standard deviation divided by the square root of the sample size. This distribution is best applied for large sample size. Says that the sample size is greater than or equal to 30. So yun. It is to be known if the mean and variance are present. Next to that, it is said to be unknown when the standard error of the mean becomes s divided by the square root of the sample size, where s is the point estimate of the population standard deviation or the sample standard deviation and n is the sample size. To estimate the population parameters, we can use the t distribution by using the formula t is equal to the sample mean minus mean divided by s over the square root of the sample size. Remember that as n, or the sample size, is very large, the standard deviation is almost indistinguishable from the population standard deviation, and therefore T and Z distributions are essentially identical. Remember that we use the T distribution for a small sample size, like say the sample size is less than 30. So let us have example for the known and unknown variance. Read and analyze the following situations. Determine whether the following statements have a known or unknown population variance. Write your answer in the space provided. Identify also the formula to be used to estimate the standard error of the mean by writing the symbol of the standard error when the population variance is known, and the symbol for standard error when the population variance is unknown. Number one, because of inclusive education, learners with disabilities are also part of the normal students. Consider a population of the PWD learners consisting of 1, 2, 3, 4, and 5. Samples of size 2 are drawn from this population. So in here, we're going to write if it is known or unknown. And then from the said answer, if it is known, we have the Z formula, or the formula for the standard error. And then formula for unknown, which is this one. So in this given, it is said to be known. So why is it called known? This is a population data. So as you can see, meron tayong population data. Although the value of the variance is not given, you can still determine the population mean and the population variance. So pwede natin kasing isolve. Kaya considered siya as known. So, this situation is an example of the sampling distribution when the variance is known. Since the population variance can be calculated by standard error of the mean is equal to standard deviation of the population divided by the square root of n. So, it is known. Number 2, given that mean is 15, the standard deviation is 6, and the sample size is 16. This one, it is considered to be unknown. The given values are mean, the sample standard deviation, and the sample size. For this, for us to find the standard error, we will use the formula of the standard error be equal to S over the square root of n. S stands for the standard deviation of the sample mean. IQ scores are normally distributed with standard deviation of 15. You wish to determine the mean IQ of all students in Matiaga National High School by taking a random sample of 16 students. So dito naman, kung i-analyze natin, ang given niya ay standard deviation at saka yung 16 students. So in this time, since given ang ating standard deviation, meaning to say, pwede nating makuha ang variance. So may variance siya. Kasi alam natin na standard deviation is always the square root of the variance. So, multiplying 15 to itself, makukuha natin si variance. So, dito, ito, the variance here is known. And then, Since it is known, ang formula natin ng standard error ay yung ganitong klase. Standard error of the mean is equal to the standard deviation of the population divided by the square root of the sample size. Next example. The general weighted average of the grade 7 applicants for admission in USHS over the past 7 years has been consistently 92.78. This year, a sample data of the applicants or GWA are 98, 89, 92, 95, 96, 90, 91, 92, 97, 93. So, we have the mean. But then, the standard deviation, or the variance, I should say, is unknown. So therefore, this is unknown. The only given values are the population mean and the sample size, that is 10. So what we're going to use for the formula for the standard error will be standard error is equal to the standard deviation of the sample mean divided by the square root of n. Number 5, a finite population composed of 6 items whose values are 2, 3, 6, 7, 8, and 10. Samples of 3 are drawn at random without replacement. So, meron tayong 6 populations and samples of 3. Although hindi talaga given yung mean at saka variance, pero pwede nating i-compute. Kasi alam natin na meron tayong population, tapos meron tayo of size 3 with undergoing a solution process for us to find the mean and variance, pwede nating makompute or pwede tayong makakuha ng value. So, kaya naman ito ay known. Kaya, ang ating standard error formula will be standard error is equal to standard deviation of the population or population standard deviation divided by the square root of n. So that would be all for this topic. May you have learned about finding the mean and variance of the sampling distribution of sampling distribution of the sample means and be able to define whether it is known or unknown. Goodbye, and don't forget to like, subscribe, and share my channel. See you next time.